Bismillahirrahmanirrahim. My dear students, here is your mathematics teacher Muhammad Amjad Saeed from Pakistan International School, Taif, Saudi Arabia. Today we will continue our lecture number 43 and chapter number 9, theorem number 9.4. The statement of theorem number 9.4 is if two chords of circle are congruent, if two chords of a circle are congruent, then they will be equidistant from the center. Here is yes, dear students, theorem number 4, chapter number 9 statement. If two chords of a circle are congruent, then they will be equidistant from the center. What is given? A circle with center at O and two chords are A, B and C, D, and they are congruent. They are congruent. Draw OH perpendicular to AB and OK perpendicular to CD. Dear students, again, what is given? A circle with center at O, two congruent chords are AB and AC, AB and CD. Draw OKOH perpendicular to AB and OK perpendicular to CD. This is given. To prove is that they are equidistant from the center, mean OH is congruent to OK. This is to prove. Before that was given. What is given? There is a circle. There its two chords are congruent with center at O. This is given. What is to prove? They will be equidistant from the center. So these two chords AB and CD are equidistant from the center, mean OH is congruent to OK. So dear students, what is given? A circle with center at O and two congruent chords are A, B and CD. Draw OH perpendicular to AB and OK perpendicular to CD. To prove is OH is congruent to OK, equidistant from the center. Now, construction is join O to A and O to C. Join O to A and O to C. So that we have two triangles OAH and OCK. Because these are perpendicular, therefore these are two right-angled triangles. So construction is join O to A and O to C to make two right triangles OAH and OCK. After that, to write triangle over here, OBC. After that, we have to write down the proof, statements, and reasons. Statement and reasons. In the correspondence of triangle OAH and triangle OCK, OAH and OCK, OA is congruent to OC, radii of same circle. Radii of same circle. After that, angle OHA is congruent to angle OKC, both congruent to 90 degree. This is given. We have drawn that. After that, AH is congruent to CK. Why? Half of congruent sides AB is equal to CD. This was given. They are congruent. AB is congruent to CD. So half of AB is AH and half of CD is CK. Half of congruent sides are also congruent. Therefore, triangle OAH is congruent to triangle OCK. That will be side angle side postulate. Even you can write down hypotenuse side is congruent to hypotenuse side because they are right angle triangle, and you can use this angle side also. If these two triangles are congruent, then you can say, therefore, OH is congruent to OK. These are corresponding sides of congruent triangles. Corresponding sides of congruent triangles. Dear students, these are corresponding sides of congruent triangle. Sides of congruent triangle. So that was your theorem number 4. After that, dear students, we have exercise questions. Exercise 9.1. We have 2 questions from 9.1. Exercise 9.1. Question number 3 and 4. What is question number 3? If the length of chord AB is 8 cm, its distance from the center is 3 cm, then find the diameter of such circle. Question number 3. Dear students, this is actually the circle. The question is, if the length of chord AB is 8 cm, this is suppose A, B, this is 8 cm. Its distance from the center is 3 cm. Its distance from the center is 3 centimeter. Find the diameter of circle. You have to find the diameter. Here is, suppose this is C and this is D. What is diameter? Basically, diameter of circle is equal to AD, which is double of OA. You have to find that. Diameter of circle is AD. Diameter is the chord which is passing through the center. And remember that OA is equal to OD. It is the center. So AD is half double of OA. So you need to find OA in fact. You know that as OC is perpendicular to AB. Remember that when the line segment coming from the center, it will be, in the previous theorem, it will be perpendicular to the chord AB. A line segment coming from the center, it will be perpendicular to the chord AB. So OAC is a right angle triangle. And also, you know that if this is perpendicular to the chord, then C will bisect AB. C will bisect AB. So you can say that AC is equal to half of AB. What about AB? AB was 8 centimeter. Here is 4 centimeter. So AC is 4 centimeter. Dear students, you have to find the diameter of circle which is AD, double of OA. So to find OA, first of all you will check OC is perpendicular to AB and OC divides AB into equal parts. You will see is the midpoint of AB, that AC is equal to BC. So AC is half of AB total, that is 4 centimeter. Now in right triangle OAC, using Pythagoras theorem, OA square is equal to AC square plus OC square. In right triangle OAC, opposite to 90 degrees hypotenuse, OA square is equal to AC square plus OC square. This is 4 square plus 3 square, that is 16 plus 9, it is equal to 25, and OA square, taking under root on both sides, OA will be equal to 5. OA is equal to 5 centimeter. Hence, diameter is equal to 2 into OA, 2 into 5, that will be 10 centimeter. Dear students, that was your question number 3 of exercise 9.1. After that, we have question number 4. Same exercise, question number 4. Question number 4. Calculate the length of chord which stands at a distance of 5 centimeter from the center, whose radius is 9 centimeter. Okay. Question number 4. The question is, we have the circle. This is chord AB, which stands. The question is, calculate the length of chord. length of chord AB. You have to find length of chord AB. And circle with center at O, and this is C. The question is, it stands at 5 centimeter from the center. This is 5 centimeter from the center, and radius is 9 centimeter. Radius means the distance of center to the point on circle. Dear students, you know that OC is perpendicular to AB. Clearly, line segment coming from the center to the chord, it will come at a 90-degree angle. And also it bisects the chord also. So OC bisects AB. That is AC is equal to BC. Or you can have AB is equal to AC plus BC. You have to find that. AB is equal to AC plus BC, but they are same, they are equal. C is the midpoint. Now in right triangle OAC, using Pythagoras theorem, is OA square is equal to AC square plus OC square. Here is 9 square, AC square plus OC square is 5 square. 81 minus 25 is equal to AC square. Remember that. So AC square is equal to 81 minus 25, that will be 56 under root. 56. And if you take square root on both sides, that AC will be equal to 56 under root. This is 56 under root. And you know that, what is 56 under root? That can be written as 7.48 centimeter. AC is equal to this one. But you know that, therefore, AB is equal to AC plus BC. You can say AC plus AC. You can say 2AC. Remember that BC is equal to AC. Instead of BC, I have applied AC again. Instead of BC, I have applied AC. So 2AC. So that is 2 into AC is 7.48. So dear students, you can have 14.96 centimeter, 96 centimeter. That is your answer. I hope that you understood this question. Dear students, that was exercise 9.1. After that, exercise 9.2, we have question number 2. AB is the chord of the circle and diameter CD perpendicular to the bisector of AB. Prove that AC is equal to BC. Here we have exercise 9.2. Exercise 9.2, question number 2. Question number 2. AB is the chord of the circle and diameter CD is perpendicular bisector of AB. Here is a circle with O and here is AB is the chord and CD. This is C. CD is the diameter of the circle, which is perpendicular to the chord AB. Which is perpendicular to the chord AB. Suppose we have point of intersection as E. What is the question? AC is equal to BC. We have to prove that. Join A to C and B to C. We have to prove that. Dear students, check that a circle with center at O, CD is the diameter which perpendicularly bisect AB at point E. We have to prove that AC is equal to BC. AB is the chord, CD is the diameter. What is given? AB is the chord, CD is diameter such that CD is the diameter such that CD is perpendicular to AB. CD is perpendicular to AB. And also it is perpendicular bisector. It means that AE is congruent to BE also. Here is. So what is to prove? To prove is AC is congruent to BC. AC is congruent to BC. So what is that? What is construction? Join A to C to A and C to B. Construction is join C to A and C to B and label the angles as shown in the figure. Label the angles as shown in the figure. Given to prove is AC is congruent to BC, construction is join C to A and C to B and label the angle as shown in the figure. I have made it a little bit simple for you to understand by having the angles named as 1, 2 and 3 and 4. Proof is statements and reasons. Dear students, in the correspondence of triangle ACE and triangle BCE, ACE and BCE, angle rather CE is congruent to CE. This is common. CE is congruent to CE common. Angle 1 is congruent to angle 2. Remember that here is angle, instead of 1, angle CEA is congruent CEB, each congruent to 90 degree, as CD perpendicular to AB. That's why these angles are equal. Each angle congruent to 90 degree. And AE is congruent to BE. This is given because this is perpendicular and the line segment coming from the center which is perpendicular on a chord, it will bisect the chord. It means that A is congruent to B. This is given. Therefore, triangle ACE is congruent to triangle BCE. Side angle side postulate. Dear students, if these two triangles are congruent, then AC is congruent to BC. Remember that these are corresponding sides of congruent triangles. Corresponding sides of congruent triangles. So I hope that you understood this question. Dear students, in chapter number 9, you can solve your question number 3 with the help of diagram. I hope that you can do very easily this question, and inshallah you will have miscellaneous exercise 9 as your assignment. Dear students, your assignment is miscellaneous exercise 9. Miscellaneous exercise 9 is your assignment. You'll solve it, and if you have any problem, you can contact me. Inshallah, I will do, and I will give you the idea how to complete it. But formally, you must solve this miscellaneous exercise 9, and inshallah, you can do it. This is the whole concept which we have discussed so far in this chapter number 9, and inshallah in the next lecture we will start our chapter number 10 inshallah. So in chapter number 10 we are given 2 theorems, or rather 3 theorems. In chapter number 10 we are given 3 theorems and exercise question also in 10.1 10.2 exercise. Yes, and inshallah we will do it. Hopefully you will revise that syllabus and you will solve these examples and exercise questions at home. And if you have any problem, you can contact me and inshallah we will do it. Okay, Allah Hafiz and Assalamu Alaikum.